Hello, I'm Dr. Collins, and in this video we will continue building up on our statistical knowledge, and in particular we will focus on the scary terms, the positive and the negative skew. But fear not, we'll make these concepts not only super easy to understand, but we will also endeavor to point out why on earth we need to know about them and what it adds to our research knowledge and interpretation of scientific data. In one of our previous videos, we discovered some bread and butter terminology of statistics, which were mean, median, and mode. We learned how to calculate these concepts and started exploring their use in helping us understand how our data is distributed. We discovered that if our data is indeed normally distributed, i.e. had this symmetrical bell-shaped curve when plotted, we could use parametric tests for statistical analysis. And if we didn't have a symmetrical bell-shaped distribution, we mentioned that we would have to resort to non-parametric tests for data analysis. And we didn't explore much how the distribution might look like in non-symmetrical cases. If you haven't watched that previous video, this is a good time to pause and get up to date with our introduction to statistics video and come back when you're a bit more comfortable with these concepts. If you've already done that or you're comfortable with what we've been talking about, let's crack on. So where we left was what the distribution might look like in asymmetrical, in non-parametric datasets. And this is where the positive and negative skew comes into play. In order to avoid things becoming too theoretical, let's have a look at this with an example. Let's say we have a class and there are 26 students in our classroom. And as a teacher, you have prepared an exam, and let's say it was a moderately difficult exam and the students obtained the following scores. A couple of students did really well, a couple of students failed, but overall the majority of students did average. When you calculate the mean, median and the mode of this data set, you will notice that they are all equal to 60. And please, by all means, if you need a bit of extra practice, this might be a good time to pause the video and calculate the mean, the median and the mode yourself to consolidate your knowledge. So, even by looking at the values of the mean, median and the mode, we already know that this will be a normally distributed data. Because remember, when a data set has a normal distribution, the mean, the mode and the median are the same or about the same. And when you plot this data on a graph and draw a line over it, you will have this beautiful bell-shaped symmetrical appearance that will further reinforce your judgment that your data is indeed normally distributed. Okay, now let's say you prepared another exam for your students for the same class, and this time you made it a bit easier and even threw in a couple of bonus questions, and therefore this time your students did a little better and obtained the following scores. Overall, quite a few students improved their scores. A couple of them even answered the bonus questions and got above 100%, and you went ahead and calculated the mean, median and the mode of this new data set. Immediately, you notice that the average of the students is quite a bit higher this time. The mean is bigger than the median and the median is bigger than the mode. So we are already anticipating that this will not be a symmetrical bell-shaped curve. So we go ahead and plot this and draw our line. As we expected, the graph doesn't look symmetrical anymore. In other words, if you were to draw a line in the middle of the graph, the two halves of the graph don't look like mirror images. So it is said to be asymmetrical. It is very obvious that this graph is skewed, but the tricky bit is understanding and remembering what kind of skew it has. This is where most people get tripped up. To determine the type of skew we have and help us determine whether this data set is positively or negatively skewed, we can use this sledge analogy. You're going to have to pardon my poor drawing skills here, but here we go. We have our snow sledges. What we want to do is we want to go down this mountain, but first we have to decide whether we want to go down the right side of this mountain, where if you look at the x-axis, there are more and more positive numbers, or are we going to go down the left side of this mountain, where number goes towards negative? I think we would all agree that with this particular mountain, the safest route down would be via the right side of this mountain, where there is a nice and easy slide down rather than a sudden steep drop down on the left side. And therefore, this graph is said to be positively skewed. Okay, we're making great progress. So let's go back to our classroom example and have a look at how things would turn out if we were to make the exam a bit harder and even introduce negative marking. This time we got some students performing worse and some even got 0 or minus grades. We go ahead and calculate the mean, median and the mode of the new scores, and notice that this time the mean is smaller than the median and the median is smaller than the mode. Again, we have a strong suspicion that this data set will not have a normal distribution, so we go ahead and plot it on the graph and draw our line, and as we expected, the graph doesn't look symmetrical again. You probably already worked out the type of skew this graph is going to have, but let's entertain the snow sledge analogy one more time to consolidate our knowledge. Okay, here we go. Our snow sledges again to the rescue. They'll help us determine the type of skew this graph has. So, what do you guys think? Are we going to go down the right side of the mountain or the left side? I don't know about you, but this time around the right side doesn't seem very appealing. So yeah, you got it. We're going down the left side of the mountain towards negative numbers on the x-axis, and therefore the distribution of this data set is said to have a negative skew. Alright, let's quickly summarize. If your mean, median and mode are the same or about the same, you will have a nice symmetrical bell-shaped curve and your data will be normally distributed. If your mean, median and the mode are not the same, you need to look which one is bigger, which might already give you an idea about the skewness of your data, and you can already deduce the type of skew your data might have. But if in doubt, you plot your data and remember our snow sledges and ask yourself, what is the safest route down the mountain? Which way would I rather go down with my snow sledge? Whichever direction is the sensible option, it gives you the type of skew your data has. Thanks for watching. I hope that was useful. If you liked this video, please subscribe to support more videos to be made. For free practice questions and more videos, you can visit the following website. Good luck!